when you mentioned the 200-watt Elastic Stack, what Elastic Stack is all about, what are the different products, different suite of products by Elastic, right? So it's kind of a very simple to understand, but at the same time, it goes a lot more thought process here as well. So on your left-hand side, you see something called Beats, whereas on the right-hand side, you see something called Kibana. In between, you have Logstash and Elasticsearch. So Elasticsearch, as I said, is an engine to hold your data and to let your data searched, right? It's basically used for searching and analysis purposes or analytical purposes, okay? And that is your heart. That is the heart of the Elastic Stack. That's what everything, all the things happen in the Elastic world, right? If it is not there, well, you can still use other parts of it, but Kibana certainly doesn't work. Logstash, you can certainly use Logstash. I'll come back to that Logstash in a second anyway. Okay, so that's your Elasticsearch is the heart and soul, which holds the data, which lets you query the data, which lets you create dashboards, which lets you analyze the data. Okay, everything is in Elasticsearch at this point of time. So keep in mind, Elasticsearch exposes the data or exposes APIs for you to query that data. So when I say exposes, it exposes via the REST APIs, right? You can use get, or you can use put, you can use your post, delete, all those 5 or 6 methods you use to do the job on talking to Elasticsearch. Okay. On the left-hand side to the Elasticsearch is the Logstash. Now, this is a really, really awesome tool, again, for dumping the data or extracting the data from multitude of destinations and pushing it into multitude of destinations. So from sources like AWS S3 or Kafka or database or file system, anywhere you think, or Twitter, for example, you get the data, right? Logstash will enable you to get the data and take the data and then push it into Elasticsearch. So that is what the Logstash data can do. Not necessarily Elasticsearch. If you want the data to be going into database, be my guest, you can do that. You can send it to Kafka, you can send it to Redis, you can send it to anything you can think of, you can send it to. So Logstash has got multitude of sources, multitude of destinations. So it kind of works both ways. So you can connect to a Twitter and you can connect to database. You can connect to file system and you can connect to Elasticsearch. You can have multiples of that as well. You can connect to Twitter and post the data to Elasticsearch, to database, to Redis, and to Kafka. It's up to you, right? Your choice of destinations, your choice of sources, right? Inputs and outputs. In addition to that, it also does the processing it. And that's one of the reasons why you like it, actually, right? It does massage that incoming data. If you want the Twitter data, that you want to remove some of the unnecessary information, you can drop that in Logstash. Or if you want to enhance that information, you can enhance that. So Logstash is actually a data processor which has got the pipeline architecture, which all it's going to do is that the incoming data is actually going to be churned through, is going to be massaged, is going to be prepared for the output to take it from. Be that output be Elasticsearch or database or anything of that matter. You don't need to worry at all. Right? Now, finally, on the left-hand side, you see the beats. Okay. If you are aware of beats, they are very, very simple concept. Actually, so it's nothing more than a simple application running on the virtual machines or the machines, right? So all what they are actually going to do is their job is to pick up the data on the place where they are being installed. So, for example, when you're running a Logstash, so when you're running an Apache web server, or when you're running a SQL server, or when you're running any of the servers, for example, those servers spit out some log files, right? They emit logs, right? And those logs needs to be brought into for analysis, or they will be going into some sort of a tool. I mean, normally you can tail those logs, but they should be going into Splunk, or they should be going into some of the tools like Kibana, right? Into Elasticsearch as well for further analysis, right? Because at some point of time, if your application is running on a VM or on a cloud, and you want to see the data, you want to see the logs, right? To troubleshoot your application, right? So beats or FileBeat in this instance, all it's going to do is that it's going to get the database that's tailing that, and dumps the data either gives the data to Logstash, or Elasticsearch. It doesn't matter wherever it's going to go. But ultimately, the aim is that its job is only to tell the file bit is only to tell the files or to get the data from the files, that is log files, right? Heartbeats are about everything about heartbeats, if the system is up and running, whether the health is okay or not. Metrics are about the CPU, the memory, the RAM, all those information about the virtual machine. So these are the beats are a single purpose data shippers. All its relevancy is about getting the data into the next level, into Elasticsearch or into Logstash for the next bit to work. Okay, so this is your Elastic Stack. It used to be called Elk Stack. From 6 onwards or 7 onwards, they started now calling it as Elastic Stack. Okay, so Elastic Stack is made up of these 4 bits of information, 4 bits of data, or 4 bits of suite of products, I should say. Okay, so that's pretty much on the thingy, and I need to jump onto something called the fundamental concepts. This is really here. Do you really care what search engine is behind there? You really don't care, right? All you're going to do is just simply use, okay, I'm sending a request, I want a response back. That's nothing more than that. Here, in this instance, my nodes are nothing more than running instances of Elasticsearch. They expect documents in the format of JSON. So JSON is the format, is this kind of acceptable format for creating a document. So what is a document? I think we haven't seen that yet. In the third hour, I'm just going to go through with you what a document is, how we're going to prepare the request, how we're going to index the data, right? That is the hour of the session. Okay. Now, if you look at a little bit in detail, so all Elasticsearch is expecting is to send it a set of documents, a document or set of documents or multiple documents, doesn't matter, right? And everything has to be in JSON format, right? Now, there is something called an indexing service. This could be a custom service or it could be an API exposed by the Elasticsearch. All you're doing is that you're sending the data to that Elasticsearch via this particular one, right? That is what it is. Now, this is your document. If you see, this is JSON document, what you see here is that it really clearly says to you that this is something which has got a little bit of, how shall I put it? Basically, it says to you that, okay, it has got a title, it's got some information about John Doe, including address as well as internal object called location and so on and so forth, right? And that is what the document is all about. Document is nothing more than just giving you that information to you, right? And if you see, this is all JSON formatted, right? Name, value, pairs inside a curly braces here and there, right? So that is your JSON. So whenever you want to send the document, whenever you want to store documents, store information in an Elasticsearch cluster, first and foremost thing what you need to do is that you need to make sure that that information is stored as JSON or is written as JSON. Okay, keep that in mind. Now there are types related to this one, which we are going to talk about that one later. Don't need to worry about it. Now, I just want to take a second here to compare this with the databases, right? Because if you are from the database world, in here I have two information. That is, you have title information or the name, date of birth, and the age of the person, as well as his or in this case it is his address, right? So you got an address here, and you got the information about John Doe, his date of birth and age, etc. On the right-hand side, you have a table. In fact, you have a set of tables. One is a student table, another one is the address table, right? In the student table, you can see that you have John Doe, etc. has been catered, plus an address ID has been given, and that address ID is actually going to point to the other table, which is address table, right? Which has got wherever the address table is pointing to, right? So that is the difference in Elasticsearch and the databases. So databases have this concept of foreign tables or additional tables of holding the data. I mean, you can still have everything in one line as well, doesn't matter, but ultimately all the data is kind of denormalized. Whereas in the normalized, whereas in the Elasticsearch world, it is all denormalized. So it's kind of you keep on getting this kind of addresses more and more. You don't keep a separate index for that. Okay, So that is the very, very simply put that one. Now, when you start up your application server, this is your typical, kind of architecture you see. So you have a cluster of 3 nodes here. You have Logstash running behind the scenes. You have Kibana for your internal users to use. And you have a search service on the left-hand side where it is actually serving the request to the client. So the client could be a Angular or a reactive client, or it could be a mobile client sending a request to your search service. Normally, Elasticsearch APIs are not exposed to the world straight away. I mean, I wouldn't do that actually. This is this is something which is not really a right thing to do. Not a right thing to set the precedence of exposing your Elasticsearch to the world. Instead, let the Elasticsearch run in its own course on the local intranet, or in the local subnet. I create a search service, and then I expose the search service via gateway or whatever the way. That's your usual architecture you should see. That comes to the conclusion about the little bit about our information about architecture side of things. But there's a few concepts that I need to show you. I need to make sure that you understand. That is, the documents we talked about, index we haven't spoken about it, shards and replicas not yet, and nodes, yes, right? So I'm just going to explain to you all these concepts in just a second. Okay, so let's jump back onto. He's asking, so Logstash is the one who cleans the data. Would that mean that I can use Logstash to transfer the data to CM like Splunk? Of course, yes. That's what it is. Logstash has got much more capabilities than what I just said in a minute or two. But it is the one which can clean the data, which can purge the data, which can enhance the data, massage the data, whatever you want. Okay, it's called really. I mean, there was a class which I did actually last month. I think if you. I'm not sure. Enhance the data, massage the data, whatever you want. Okay, it's called really. I mean, there was a class which I did actually last month. I think if you, I'm not sure whether you will be able to get the recording or not. But otherwise, you should have. You may find it in somewhere actually online as well. Can or should beats communicate with Elasticsearch directly? Of course, they can. GR. Yes, they can. They don't need Logstash in between. All the raw data coming from the beats, they can go directly to Elasticsearch without a Logstash in between, right? The reason why you want to keep a Logstash is you don't want all the stuff coming out from Elasticsearch, from beats to be entering to Logstash. Instead, you want some bits that you want to drop off, some bits you want to add, some bits you want to collate, and those kind of things. That's the reason why you want to have Logstash. But if you think that you want every raw data coming out from beats to go into Elasticsearch, absolutely can do that. There's nothing's asking you to. Nothing's stopping you to do that. Sorry about that. Okay. So this is the first ever time we are doing this job. Okay. Normally I do it very quickly earlier, but let's see actually. Okay. So what I'm doing is that I'm just going to use something called students. Okay. And this is the format I'm going to use. I suppose I'm sharing my screen. Hopefully you see my screen as well. Okay, let me maximize the screen so that you see a little bit better. So here, I'm following a particular format. Okay, I have a JSON document here, and I have a URL here. The URL is a little bit strange, but ultimately it's very easy. So you have a method, a HTTP action called put or post. You can also use post, but I'm going to explain to you why. What's the difference? There is something called a students, right? So this is basically, thanks A for that confirmation. We can certainly see the students. This particular guy is called an index. So basically, all is going to happen is that. Let me write it down here. So you have a action, right? That is action. Let me do one thing. Okay, that's the action. That's your HTTP action basically. Once you have HTTP action written there, the following one is going to be a index. So this is important. Index name. Okay. Now, followed by index name is the doc, is the type actually, but you don't need to worry about type. But that stays all the time the same way. What I mean to say is that this is actually going to be like that all the time. it's a kind of a hanging thing from the previous generations. We used to have something called types, but that types have been changed. But doc and is still hanging around, but that's all right. There's also a different way of using the doc as well. But yeah. Now this is called index name. Now you may be confused, or you may be wondering what is the index. I'm going to explain to you that in a second. In the final thing is the ID of it. Okay, that's what it is. Now all I'm trying to do is that I'm trying to have a student called John Doe, right, or John Smith. John Smith is my student, and his age. So I'm just going to put age. Let's say he's 19-year-old. Okay, these are the 2 bits about my student, right? So I'm just going to use this 2 information. Remember, I'm enclosing that into a JSON document, and I'm adding the JSON document to the end of the URL. Okay, I simply click the button. Hopefully, if my Elasticsearch is up and running, it should go and do the job of creating that document. If you see, I got a response back saying that 201 created here, right? It took about 2.8 seconds, which is actually high in this case, but anyway, doesn't matter. If you look at this one, so it said your index was created, and the index is actually students. The result seems to be created. The version seems to be 1. The ID of the document is 1, and so on and so forth. How many shards you got, and so on and so forth. Okay, that is what the idea. That is what it has told us. Just for fun's sake, now get the cluster health now here. Can you expect what you're going to get it here? Remember earlier that was green, and all of a sudden now it's gone to yellow, right? I should have shown you just before this put as well. This comes to the point of replicas not being created. Okay, I will tell you what replicas once we come back again. But for now, just take my thingy to say, because there are no replicas, and that's the reason why the status has been degraded from green to yellow. Okay. Now this is your first document you inserted into, or you indexed into Elasticsearch. Elasticsearch did not have an index called students, but it was happy to take that and then create it for you. Students index is actually nothing but a table in your Elasticsearch. Just like a table in a database, you hold the data of a particular category into a bucket or into some collection, and that collection is called index. In this case, the index is called students. You can have flights, you can have trades, you can have movies, whatever the types you want, you can have them. So all the documents about movies, they will go into movies collection. I mean, you can name it. Actually, it's up to you. The name of the index, what you want, is up to you, right? So it's nobody's asking you to use any fancy names here. It's up to you how you want to use it. Your application, you can do that. In this case, I want to put all the students' names into students index, so that's what I did, right? And each of the document has got index called 1. Sorry, not each of the document. This particular document has got an ID as 1, right? I can simply add this kind of a documents, like I don't need to do again and again, but all I can do is that I can create a second document, right? For not so intelligence of me, I'm just going to create Graham Smith. Has been created as well. Now I got 2 documents in there, and if I want to get that documents, I can simply say search. That if I do a search, right, that should give you the data straight away to you. 2 documents, right? So these are the 2 documents. I know you see a lot of things here. When you do a search, you see something called how many shards were executed and what are the hits, and hits, how many you got returned. Did you get 2 of the documents, or did you get more than 2? If it is 2 equals, means actually you got exactly 2 documents, right? and so on and so forth. I mean, you can see this, and what are those hits? You got a hit of, this is my metadata for a document, but this is your actual source, right? So this is your source of the document, what is been written. But ultimately, what you have to think about is that I got some hits, right? So basically, when I call this cluster, so when I call this student search, I got some hits, and those hits are nothing but the 2 documents what they've been set or indexed into the database or into the Elasticsearch. Sorry. So we will. So I mean, this is the first ever time we indexed a document to Elasticsearch, which turned our Elasticsearch into something called a yellow state rather than having a green state. That means actually we need to do something for that state to become yellow to green as well, right? Or at least we need to understand what has happened as well. So when you come back, I have to let you go for 5 minutes. When you come back, we're actually going to go a little bit more in the setup done, the configuration done. We know we learned how to set up a 2-node cluster and so on and so forth, right? In this last hour, we have done a little bit more on to say how we can, probably basic concepts, as well as a little bit of architecture. And then we started playing with the Elasticsearch by indexing some documents. That's where we left in the last session and the last hour. Now we're going to take it from there and dig a little bit more in detail to understand what are the bits, and I think I'm sharing this one. Yeah, that's good. What are the next steps here? Okay. Now, probably if you have already done your, if you already have your Elasticsearch up and running, this should be able to be. You can be able to do this quickly. Okay. Alternatively, also I can tell you this one: if you don't have the Elasticsearch, and if you have your console up and running from your interactive scenarios, you should be able to do that there as well. For example, I should be able to put a document here as well. Let me increase the size of this guy. Is fine. So in this case, if I do that, put students one, I should be able to do the same thing actually. Okay. Again, hopefully it's not going away. I think maybe most likely my Elasticsearch server might have died, but anyway. But you get the idea, right? So you can certainly use the interactive scenarios playground for you to go through that document. For you to go through this. For you not to worry about Elasticsearch setting up. Instead, use the Kibana dev tools to go through, do the job of. You can do all these code examples on there anyway. Okay, so let's go back to our console. So we got we put the documents now. We done this search, but remember this is not necessarily a search as search because we haven't given any inputs. We simply asked the Elasticsearch to give me all the documents that are available in students. We did not search for Graham. We did not search for John. We did not search for Grace. Nothing, no search, right? It's just basically say blanket search. Give me all the things what you have in that students, right? So, as I mentioned it to you in the second hour, basically this is an index, and inside the index we dumped 2 documents. So one document is Graham, another one is John Smith. This time we wanted to understand what is an index is, and then we'll go forward a little bit, right? Excuse me. So basically, as I said to you, index is nothing but a collection of these documents, right? You start indexing those documents, and those documents will start. So those are the documents which are going to be held in some place, right? Let me go back to my drawing board. If you look at, let me recreate that. So this is your person, okay, or a student. Student has got a name. Sorry, the student has got a name. Student goes to age. So this is your student 1, right? Now you are actually sending it. By basically via your Kibana, you are actually invoking a command on the Kibana to say, "This is my document. Elasticsearch, can you check it and then index it?" So Elasticsearch, which is sitting here, right, which is Kibana is sitting there, it kind of, you are just giving the Kibana, and Kibana is actually invoking that or sending that API on the Elasticsearch to say, "This is a document, can you take it?" Now Elasticsearch is really happy to take the document. It knows few things from the document. It says, okay, I need to put it into a document, an index called students. So it's going to go and check, does it have students index? So that's the first thing it's going to do. Students. It has got students index. Well, in this case, it doesn't have it because remember, first time when you're creating, it doesn't have that students index, right? Now this is the time where Elasticsearch is going to behave differently to the database world. In the database, if you're going to set some information into database where the table doesn't exist, it will say, oh, sorry, mate, your table doesn't exist, so I'm going to throw you an error, and you deal with it, right? In Elasticsearch world, it doesn't work that way. I mean, actually, it's more than happy to honor your request of creating your document in spite of you not having the account. So, for example, just like if you go to your bank, and if you want to put your money into the bank, and if it is the first ever time you're walking into that bank and you never had your account, that bank is going to be very cross with you. Said that, I mean, they're happy to take the money away, but if you say that I want money, take money, some £100,000 from your bank, they'll not be happy at all, right? So you need to create an account. You need to make sure that the account is processed, right? Something like in a database world as well, you need to create the table before you start using it. Elasticsearch world, you don't need the students to be created for you. Instead, you can let the Elasticsearch create that student for you. Of course, there are downsides to that, which we are not going to discuss that now. In the mapping, when we talk about the mapping session, we are going to do that actually. But for now, just take it away that Elasticsearch is actually be happy to go and do the job of creating the index for you. So now it has created this bucket called students, right? By the way, this is all in the same Elasticsearch world, okay? Don't consider something else. So this is a bucket actually. So let's say bucket is like this, okay? Now in this bucket, it's going to start putting S1, right? That's what it's going to do it. Now, and obviously if you have S2, it's going to do S2 and S3 and S4, etc., right? Now, this is as simple as like, setting that, putting the data into Elasticsearch, right? Now, there is a lot more things that will go behind this, right? So the minute Elasticsearch is getting a document, to the minute the document is flushed to this file store or to the database, there is a lot of analysis that happens in between. Remember, when you're searching, that search is actually going to be passing through the similar kind of analysis. I mean, okay, I don't want to confuse it, but just take this point away from here. Elasticsearch has to do a lot of grunt work beforehand so that the search engine is actually capable of giving you the queries back when you ask them, right? So what I mean to say is that like Google, for example, do you think that when you do search on the Google, do you think that it's actually going to go real time to all these sites, what is called, and finds out there, and then say, oh, I'm checking for Wi-Fi or I'm checking for Elasticsearch sites. So it's going to go to Elastic sites, it's going to go to Guru sites. It doesn't do on real time. All it's going to do is going to consult its own database, and from its own database, it's going to pick it up. But behind the scenes, how is the database primed up? It's got spiders which goes through the web, World Wide Web. It's going to get the data, it's going to get the data, churn the data, analyze the data, and then push it into the database, right? And then anybody who's coming to query it is going to pick up the data from the database. It's not going to go to invoke the spiders to go and check the data now, right? It doesn't care about that. And if that is the case, you wouldn't be able to get this a fraction of a second, the data back to you, right? So that grunt work, what Google is doing, is also any of these engines are supposed to do. Elasticsearch is no different. So Elasticsearch, the minute you give a document, it's actually going to take the document, take the simple document, and start building or start something called analyzing the data. So whatever you put the data here is going to analyze the data, and part of that analysis is actually going to create something called inverted indices. Okay, that's a inverted index is basically for each field is going to create an inverted index, and that inverted index is nothing but if you look at your book, right? Remember, in a book you have on the end of the book you have a key where you search for a word, and the word is told in the page number right here, right? So if you search for a word, let's say Mr. Konda, and this Konda is actually is mentioned in, let's say, page number 41. This is your index in a book, right? If the inverted way is that you basically check the document and search for based on that particular document, where are the words that are available, right? Alternatively, the way you should think about is that the data what is in that particular. So actually, we'll take an example. That's easy. Now you have that Graham Smith, right? So this Graham Smith, right? In the name field, is going to create an inverted index for the name, and it also created an inverted index for. Actually, it won't create an inverted index, but it's going to create a different data structure for age, because age is a numerical factor, it won't create the inverted index, right? It will get binary index of sorry, some other, but numericals is going to create a different data structure. It just skips my mind at the moment. Okay, so now this Graham Smith is now going to be sitting in this data structure called data structure called inverted index by splitting like this actually. So here it says it's going to create this data structure. It's going to be saying Graham is going to be capitalized to small, right? It's Graham, right? And it's going to say document ID. Right? It's going to say document ID. And the document ID, let's say this is document ID 1, for example, this is 1, right? So it's going to say 1. At the same time, it's also going to create another record in the same inverted index and says Smith is in the second, Smith is also created, but it's in the document 1. Now, let's suppose you index the second document. Let's say you index second document with John Smith. I think it's the other way around, but anyway, you understand what I'm trying to say here anyway, right? John Smith is also going to go through the same analysis process. Let me change the color so that you don't get bored with the same color. So it goes to the same Elasticsearch process, analysis process. Now that name field is actually going to be split into two parts, that's John and Smith. They will be lowercased and they will be set up into the inverted index. Remember, for the name field, I told you that there's already an inverted index created, and that's exactly what this is, the inverted index. So that inverted index is now going to be expanded. Now it's going to say, oh, it's got John, but John is not already there. So I'm just going to put a John here. Okay, that's fine. By the way, it's going to be small John, right? And which document it is in is document ID 2. That's perfectly fine. And it picks up Smith. Now Smith, it won't write it here because there's already Smith here. So it won't write it. Instead, it'll say this is available in second document. So it's going to say this is my second document. That's what happens. Nothing fancy there. All he's going to do there is going to chunkify. He's going to create. He takes your document, he splits the document into whatever the fashion you ask it, and then creates an internal data structure. And then once the internal data structure is created, like for example, if this internal data structure is created, then it's going to be stored into the database or into the file store in this case, right? That's the idea. So once a document is indexed, the index is actually going to be processing of that document into the inverted index. And once the inverted index is created, you're going to send the whole document, right, into your file store. Now, this is where the search is going to come into picture. So you have now created this inverted index inside here. The alternative to that is, how does the search work, right? Let's say I'm the candidate. Let me go up to a reddish guy or orange guy. So I'm the candidate here, right? Now I'm doing some search. So I'm just going to search Elasticsearch to give me Smiths, okay, all the people who are like Smith. I'm going to show you that in a query as well, but just follow through that. So Smith is going to be hitting the Elasticsearch. Elasticsearch, from the Kibana it goes to Smith, is the query is going to go to Elasticsearch. Elasticsearch now goes through that Smith, right, in its internal data structure. It's going to remember that inverted index is there, right? The same thing which is here. It's going to say, okay, where is Smith available in this inverted index? Oh, Smith is here, right? Okay, that's fine. Now, what are the document IDs for the Smith? Looks like there are two documents, which is 1 and 2. Perfect. Now, what is going to do is that is got those two documents. Is going to ask the next available thread to go and pick up the document ID 1 and document ID 2 and return back to the client. That's as simple as that, because it has to do that job. Otherwise, you won't be able to go and search the database directly. Instead, you are going to be searching the inverted index for the data, right? That's the search mechanics. That's the, if you want to take away, that is the easiest concept I can tell you. Okay, that's really nothing fancy there. All you got to worry about is that the data which is going in through Elasticsearch, that needs to be processed, and that process is called text analysis, and that is the one which is going to create an internal data structure called the inverted index. And inverted index is the one which is going to keep a track of your search words or the document in a split, the words which are split from the document against each and every document ID, right? And once you have that one, even a librarian will be able to tell you that where the book is. If he has got that list of items, the document is, I mean, what is Elasticsearch has to do? Nothing, right? Of course, it's got to do a little bit more than that, but you're already cheating the system by creating these IDs for you and documents and names and everything, right? In a way, that is what it is. Elasticsearch or Google or any of the search engines, the efficient way of keeping this track of these things is the better for them, right? They don't need to do more work when a search query is passed. Instead, they have to, all the hard work is already done during all the battle is already carried out during the indexing time. Okay, hopefully you have understood that concept. I had to send you a pulse check. Hopefully you haven't, so that it can serve the client who is coming back later on. Okay, that is what the idea is all about here. Okay, so that's good. Now let's see the concept of how the data is actually stored, right? So let me quickly go through the search criteria, and then once I have the search, then I can just go through with you the shards and the other things. Okay. Now remember, I was talking to you about constructing a query or making. What I meant is that in this here, I'm just going to carry a search on Smith, right? I'm just saying that somebody is asking for a student called Smith, right? How do we write that query? So what you do is that you simply use the get or post or this one, and then you use a endpoint called search on your index and write a query. Now this is something called DSL, or a domain-specific language, query domain-specific language, which is created just for Elasticsearch, right? First you write a query, right? Query is nothing but is written like a JSON object. Inside the query you write, I mean, there are multitude of queries, but for the time being, we take a simple query called match query. Now, match query is the simplest one or the most common one we use all the time or most of the time. Here, I am going to search. All I'm saying is that, remember, this John Smith or Smith is in one particular field called name, right? So that's what actually is asking for. What is the field you want to use? You want to use name or you want to search against age? I want to search against name, so I'm just going to put the name. And what do you want to search? You want to search Smith? Okay, that's fine. Go ahead and see actually. If this is your first ever search query, remember that, okay? We constructed a search query. Now we are going to send the search query from Kibana to Elasticsearch. So Elasticsearch has got the query, and look at that, right? So if I pause here, you can see that I got two queries come back, John Smith and Graham Smith. Sorry, two results have come back. That means you have received your data back to you by, basically this is a simple query. Sorry, this is a query. This is a search query. That means you are asking Elasticsearch to give documents for Smith, and it has given you this one. Now, the takeaway point here is, can you see this? A score for individual documents as well as for the max score as well. So each of the individual document, what has been returned to you, has been identified, has given a certain score to you, right? So what I mean to say is that in this instance, Elasticsearch thinks that these two documents, what has been written, have a relevancy of 0.18. Okay, don't worry about the actual number itself, but just think of it as a mechanism of showing this the data back to the client, in the sense like there could be some other document, right? Like for example, let's say I put another document here. I'll just to explain to you once more second. Let's say I got third document, but this time instead of John Smith, I put John William Smith. Okay, so it doesn't matter age. I'll just put this one. Now I run the query again. Now, where do you expect the John William Smith to reach? You think that is going to be end of the thing? Yes. And did you see this is 0.14 and this has decreased? Is the relevancy score for this one has gone a little bit down. What I mean to say is that in this instance, the Elasticsearch, your engine, thinks that whatever you're searching, Mr. Smith, this guy is kind of irrelevant to these two guys. So that means it is actually going to say these two documents are at the same level. So it means it thinks that Mr. John Smith and Mr. Graham Smith are much more important to you than Mr. John William Smith. Now, if you're clever enough, or I shouldn't say that, you're very clever than me, this particular question has already popped up into your head, right? Okay, why this particular John William Smith has got a lower score, right? Now, there are other, we're not going to see that now today, but there are algorithms for best matching, basically something called BM25, best matching 25 algorithm, which creates this score, or which kind of puts the score onto individual responses. So what I mean to say is that it's something called a concept called a term frequency, or something called IDF, inverse document frequency, or a field length. Okay, so what I mean to say these three is basically it's a concept which I will explain to you in the coming lessons, but just go away with a little bit of understanding in this one. Here, remember we are actually asking the Elasticsearch to dump the data into a store, but before that it's going to be analyzing the data, right? That analysis, during the analysis process, is actually going to say what is the frequency of the term. So basically, in this instance, the frequency of this particular term across all the documents is going to count that. It also says the frequency of the term across this is inside the document. TF is term frequency of that particular term in that document. Has it appeared once? Has it appeared twice? Has it appeared three times? That is what the frequency. Inverse document frequency is all about that particular word. Has it appeared across the all stash of documents? So if you have 1,000 documents, is Smith appeared in X number of documents 5 times, in X number of documents 3 times, and in other documents 0 times. In that case, the one where you have 5 times appeared, that is the highest relevant document, right? So that's the inverse document frequency. But inverse document frequency is all about the document, the frequency across the whole of the stash, right? Whole of your document. Now, in this instance, field length is the one which is going to come into picture. So what it means is that if you look at, if I'm boring you on this one, just bear with me because this is a really important concept, but we'll come back to that as a later part as well. But if you really put your head into it, it's really, really amazing actually. It's really enjoyable algorithm, really. Look at this, right? The Elasticsearch thinks that here Smith is in 2 words. So you got Graham and you have Smith, right? So there's 2 words, whereas Smith here has got 1, 2, 3 words. So Smith, that is whatever the criteria you're looking for, is in 3 words rather than in 2 words. So that means it thinks that my search word, if the search word is actually in relatively less number of words, it is actually much more relevant than if it is in a bag of words. It's more words. That means maybe less relevant. That's what is actually aiming. If you do one more of this thing, I mean, again, I don't want to bore you on this one, but it's really, really important. It's really enjoyable concept. I can go on and on actually on this concept, but that's not what we're here for. If you put one more Smith in here, okay, and see what happens. Let's say this is 4th document. In this instance, let's see what happens if I do run. Did you see that? It has got the Smith, that is this particular document as the high score, because it knows now that repetition of the same word in the title field or in one field is much more relevant than having only once. So basically, if you go to a BBC site and if you search a particular text, right, URLs, if that particular word is appearing more than once on the title of the BBC, for example, that means it's more relevant. It's more relevant for your article, what you're reading, right, or what the user is using. That's the concept behind it. But again, if I'm boring you with this one, do apologize and do stay back. Actually, maybe we'll pick it up in the next session. Okay, so let's jump forward a little bit. Now that is all about. Let me clear this up. Okay. So we got an index, we created an index, and the index has got documents, right? The index has got quite a few documents. We managed to set the document. we index those documents, and then, as I said to you, index documents are going to be processed, creating all the inverted index data structures and so on and so forth. Right? We don't need to worry about at this point of time the integral matters of that one. But the things what we need to understand is this guy. If I invoke get students, I'm searching this. Yeah. If I index, if I invoke the get method on students, I get some information like this. So if you see that students, remember the students is equivalent to your table in a database. It's a bucket, it's a collection, it's something which holds all your documents. It's called index in NoSQL databases or including Elasticsearch, which is just something nothing more than a database. Sorry, it's called a index, right? Now, each of the index has got some sort of a settings. You can see there's aliases, there's mappings, and then settings. Aliases are the alternate names. Mappings are really important ones, which we are going to see that now. Settings are the ones which are actually going to help you to create shards and replicas. Okay. Now this is where we are going to start. Settings is going to say that number of shards are 1 and number of replicas are 1. Now this is where we are going to start drilling down into shards and replicas concept. Okay. I may have to jump back onto my drawing board. Hopefully you don't shout at me by giving all this handwritten notes, but hopefully that will help you as well. Okay, so we are talking about the shards, right? So remember we created when we indexed something called students into Elasticsearch, I told you that Elasticsearch went ahead and created an index, right? So it has, let's suppose this is Elasticsearch, and inside the Elasticsearch, once the student document has received, this is a student document from the Kibana. When the student document is received, this is the student document is received with this document information. It went ahead and it created in the node. It's created something called students. Sorry, something called shard first. Sorry, before I start, my bad. So I'm a bit distracted with my dog shouting there. Sorry, it's created something called an index. Okay, because remember this is a student's index, right? And this is what it is. This is a student's index, right? So it created the student's index, perfectly fine, and it has to dump that document into this index. But it doesn't stop there, because student's index is the index is actually a very, very loosely focused term. Basically, it's a kind of it's a logical structure. It's a logical structure. It's nothing but a logical structure. Okay. Now, this logical structure is made of some physical entities called a shard or shards. Okay, and I'm going to put it in a what you call dotted line, because I don't want to be told of later on. That is called replica. Okay, so you got a shard and you got a replica. These are called primary shards. So primary replicas, and the shards and the replicas. So what I mean to say is that a logical collection is created for you, but that logical collection is backed up by a shard. Now, in the first hour, I have introduced to you a library called Apache Lucene, right? Remember that Apache Lucene is a Java-based library, and that library is actually nothing but a shard. So in this instance, whenever you create an index, Elasticsearch is going to go to ask the Lucene to start a shard for us. So you have created a shard. This is a Apache Lucene running of that. So this is an application that is inside your big application. This is a small application running. That's your shard. And the ability of shard is actually, that is the Lucene is actually going to do is that now, because you index the data, those documents, remember that inverted index needs to be created. That will be done. Let me pick up another color to distinguish. Right. So the inverted index is created. In addition to inverted index, it also opens up something called segments. Okay, something, don't worry about that one, but ultimately it's going to flush the data to your file system. Remember that logs directory and the data directory, we talked about it. that data directory is where your files are going to be sitting in. So your student, when it has gone to the index to the shard has picked up that, it created the inverted index, it's created some in-memory data structures, and ultimately it flushed that document to the database, to your file system. That is the overall concept of a shard, an index, and your Apache Lucid, right?